Most functions that we deal with are going to have an infinite number of elements in their domain and range. We're not going to have just a list of numbers. So we need a way to be able to describe an infinite set of numbers, and we do that using set notation. So here is an example of a domain that might be given in set notation. And let's go through what all these bits mean. So first of all, we have this curly bracket at the beginning. The curly bracket is just read as the set of. So we have the set of. Then we have this x bit here, so the set of all x values. And we have the colon. Now sometimes this is just represented by a small vertical line or a colon, both gets used, and that is read as such that. So the set of all x values such that. Now we have this inequality part. The inequality is as it is here, as we know what that means. X is greater than 6. We use a comma to mean and, to split up different criteria for these values of x. And then we have the second part of this, which is x belongs to the set of real numbers. Or in shorthand, x is a real number. So this statement in total reads the set of all x values such that x is greater than 6 and x belongs to the set of real numbers. All that really means is the domain is all real values of x greater than 6. Now quite often this will get abbreviated to just this without all the set notation, or even just this, x is greater than 6. And that is a shorthand for this whole thing. Generally speaking, if we don't define a number set, like I have here the real numbers, if we don't define one, then the number set is the real numbers. If we want it to only be integers, we would specify integers. So x is as an integer using the Z symbol, or rationals, or whatever it is. So if we don't define something, we're going to assume that it's real numbers. So this is the notation that is used in the IB. You might see some other notations used in textbooks, and that's called bracket notation. Bracket notation uses square brackets to represent this. And in bracket notation, this would be represented as, so you essentially write it as a coordinate with the lowest value and the highest value. So 6 is the lowest value and the highest value is infinity because it's anything above 6. And then we use square brackets. If the square brackets face in, it includes the value that it's next to. If the square brackets face outwards, it doesn't include the value. So here we don't want to include the 6, so we face our bracket outwards.